would like to pitch you our paper, Improving the Methods for Determining the Promising Boundaries of Iron Ore Open Pits. One of the key parameters in the design of open pit mining is determination of carrier boundary. Currently, the upper horizons of most iron ore quarries are approaching their final boundaries. So, the operation of open pit will be characterized by the achievement of the highest burden ratios. This will lead to the fact that the cost of ore and, in general, the cost of production of concentrate will reach acceptable values. Accordingly, the value of operational overburden ratio, which determines the final borders of open pit, can be reduced by selecting the direction of development of mining and current definition of rational contours on the surface. Reducing of the operational overburden ratio will increase the final borders of open pit, thereby increasing the ore reserves in the contours of quarries and industrial potential of the mining and processing plant. The necessity now to determine the final borders of the open pit, due to the fact that after reaching upper horizons their final position, the carriers will work in the mode of annual loss, it means outflow of production capacity. The preparing of overlapping such reduction will take 5–7 years with any method of development. This will increase the depth mining, and most of the upper horizons of the working area will be repaid, which will require much more investment in stock exploration on the approved final open pit boundaries. However, existing methods for determining the critical overburden ratio do not consider the possibility of its changing due to variability of technical and economic indicators, including the cost of ore in a competitive environment. Therefore, the goal was set to prove that the critical overburden ratio is not constant but changes over time, and it will significantly depend on the final depth of the quarry. Idea of the paper: when determining the critical overburden ratio, it is necessary to take into account the dynamics of the external competitive environment of the mining enterprise and determine the boundaries of open pit mining based on the fact that the cost of ore mining in the projected open pit should be no more than in other enterprises of the same market that mining both open and underground methods. Many calculation principles of determining quarry boundaries are based on the fundamental: the allowable cost of ore mining should be more or equal to the cost of ore mining of the designed open pit. Formula 1. It should be noted that the allowable cost is taken as the cost of ore of one of the basic mining company's competitors with the open pit method of the deposit development. Moreover, the allowable cost ore is taken for as it is at the time of designing a new carrier or reconstruction already working. The expected cost of ore for the projected quarry is calculated depending on the value of the overburden ratio by Formula 2. After substituting the expected cost of mining ore and transformation of inequality 1, Formula 2 takes the form like the Formula 3. It's here. The left-hand side of expression determines the value of the critical overburden ratio, and then taking into account expression 1, 2, and 3, we obtain inequality 4. Based on the above, the condition of competitiveness designed carrier could be summarized as follows. Overburden ratio in a carrier that is designed should be less than or equal to critical overburden ratio that takes into account the current economic development indicators of operating enterprise. It should be noted that in the regulatory documents, the calculated critical overburden ratio to determine the final depth of the open pit is taken as a constant value. However, the basic competitor continues its work and over time will change its economic indicators, in our case, the ore cost. The reason for this is the change in the current overburden ratio to greater or lesser extent. Let's consider on an example of two conditional basic open pit competitors. Possible change of current overburden ratio, sheet 4 and 5. In the conditional open pit number 2, in contrast to the considered open pit number 1, the boundaries on the surface have not yet approached their final position, and further development of the core is carried out with the development of mining as in horizontal direction, here and here, and in the depth. In figure 1 and 2, the numbers 0, 30, 60, 90, and 120 indicate the stage of reduction of mining operation in conventional base quarries competitors every 30 meters. Mining condition of working wall on the stage of 0 characterize the current state of mining in the open pit and serves as a starting point for further research into their development. To determine the final depth of the future conditional projected quarry, selected characteristic section of the field. As in the conditional base competitors number 1 and number 2, and for the conditional quarry that is projected, from the position of the working walls at the 0 stage, we build their future position at the stage of mining development every 30 meters in depth. At each stage, we determine the volumes of overburden, and here is ore. And then we show these results on and calculation in a table on the sheet 6. For the projected open pit and basic operating pits, we build the schedule of change of current overburden ratio on stage of decrease in mining operations of basic and designed quarries. This schedule is here. Also on the graph we show the line of the calculated critical overburden ratio, line 1. Based on the accepted mining and geological conditions of development of conditional deposits, the current rate of discovery in the future operation of the conditional base pit number 1 will decrease. In the future operation of the conditional base open pit number 2, the current overburden ratio will increase until the design boundaries of the quarry on the surface are reached and then gradually decrease. Here is extremum. This change is the current overburden ratio is shown on this sheet by lines 2 and 3, here and here. In these cases, the current overburden ratio of conventional base pit number 1 and number 2 are critical overburden ratio for conventional pit that is projected. If we calculate the critical overburden ratio for the newly designed pit without taking into account the time-varying current overburden ratio of the base pits number 1 and number 2, as accepted for the present research, it will be constant, like the line number 1. The intersection of the lines 1, 2, and 3 with the line of current overburden ratio for conventional projected pit, line 4, provides solutions for determination of final depths of open pit. The graphical solution for determining the final depths of conditional pit, which is projected, is presented on this sheet number 8. Sheet 7 and 8 shows that the deviation of the final depth of the conditional projected pit, which is determined by comparing its current overburden ratio with the current overburden ratio of conditional base pit competitors from the final depth determined by constant critical overburden ratio, disclosure is from 14.45%. It follows from the above that to determine the boundaries of the projected pit, the critical overburden ratio must be determined taking into account the possible change in the volume of extraction of overburden and or mining at basic competitors. That is, taking into account changes in their current overburden ratio. To confirm this, the design data of Kuttybayev open pits were analyzed and we presented it at the sheet 9. As can be seen from the table, the current overburden ratio at basic enterprises are constantly changing over time. In addition, the indicators of each enterprise is subject to different trends. They can grow, decrease, or be relatively constant. So, conclusions. A new method for determining the final open pit boundaries has been developed, which differs from the known ones by taking into account the change in the critical overburden ratio in time, as well as determining the impact of technological indicators of competing enterprises on the final depth of the projected pit. It is proved that the deviation of the final depth of the projected conditional pit, which is determined on the basis of comparing its current overburden ratio with the current overburden ratio of conditional base pit competitors from the final depth determined by constant critical overburden ratio can be from 14 to 45%. Thank you for your attention. Please, questions.